Telling you again, what you need is just a slap around to make it.
Hello and welcome to the practice problems video for arc length and speed. Okay, so in this question we're going to compute the length of r of t, which is equal to 2t, ln t, t squared, over 1 to 4, the interval 1 to 4. So 1 is like our a value, right? And b is like our, 4 is our b value, okay? So we're evaluating from 1 to 4. Alright, so let's refresh. How do we find the arc length? So S is going to equal integral from a to b of the magnitude of r prime of t and then dt. Okay, so we have to do a couple things. So let's first of all start with finding r prime of t, okay? So all we have to do is take the first derivative of each of our components here. So that would be a 2, a 1 over t, and a 2t, okay? So now let's find the magnitude of this. This is actually our velocity vector, remember that? So anyways, we're going to find the magnitude of it. So we get prime of t. Okay, so we're going to square each of the components separately. 1 over t squared and 2t squared. We're going to add them together, all right? And then stick a square root sign over them. Okay, so this simplifies to 4 plus 1 over t squared plus 4t squared. Okay, all under the square root sign again. So this is equal to, now let's simplify a little bit. So we're going to, let's see, what are we going to do? Oh, we're going to find a common denominator, because that's what we do with fractions. So we'll have a 4t squared over t squared plus 1 over t squared plus, and then we'll have a 4t to the 4th over t squared. Okay, so now we found our common denominator, and now let's add everything. We'll kind of just squish it all together. So then we have 4t to the 4th, I'll put the highest power in front, 4t squared plus 1, okay? And then this is all over our t squared. Okay, so now on top, if you'll notice, I'll move on to the next slide, okay? So keep this last thing in mind here. So on top, what we actually have is something that can factor. So we have a 2t squared plus 1, and that is squared, okay? That's what made our 4t to the 4th plus 4t squared plus 1. Okay, and then we have a t squared on the bottom, and we have our square root sign still. But now, this square root sign, we have two things that are squared inside, so that'll cancel with the exponents. So what we end up getting is a 2t squared plus 1 over t. Okay, and you can, again, simplify this even more and say that 2t plus 1 over t. Okay? So that's that. That's the magnitude of r prime of t. So I'll just write that down here. This is our magnitude of r prime of t. Okay, so now to plug it into the arc length formula, right? So S is going to equal integral from a to b, and remember our bounds were 1 to 4. That's where t ranged on. And then we're just going to plug this in. So we have a 2t plus 1 over t, and then a dt. Okay? So now we're just going to integrate like normal, like we know how to do. And this is going to turn out to be a t squared, and then plus an ln t as t ranges from 1 up to 4. Okay, so S is going to equal, now we'll plug these in. So we have a 4 squared plus ln 4, okay? And then minus 1 squared plus ln 1, all right? So the ln 1, that's just going to be 0, right? And then we have 16 plus ln 4 minus a 1. So what we're going to end up with is a 15 plus ln 4. Okay? And that's it. We're done with this problem. This is the arc length given the parameterization r of t, and that t ranges from 1 to 4.
Much, 'cause you're high.